This is the question asked in today's skillrack daily challenge. So in the first line of our input, we are given the values of R and C. So here R is equal to 3 and C is also equal to 3. So we have to accept a 3 cross 3 character matrix as input. And after that we are given 2 points. So here the first point is 3 1 and the second point is 1 3. So now this is the point 1 3 and this is the point 3 1. So our task is to connect these 2 points and we have to calculate the minimum distance to reach the first point to second point. And the cost to reach the point is nothing but the alphabets present between it. So here if the alphabet is equal to Z, then the cost to reach that particular point will be 26, and if it is A, then it will be 1. So as per the alphabetical order, we have to calculate the path distance. So now there are two possible ways to connect these 2 points. So first we can make the row equal and then we have to make the column equal. So we will be traversing like this. So this red path will be the first possible way to connect both the points. So now we shall calculate the cost for this particular path. So A is 1 and then another A, so 2, and then another A 3, and then B, so B is equal to 2, so 3 plus 2 5, and then another next is also A, so 5 plus 1 6. So the total cost for this particular path is 6. So now I will remove it. So the next possible way to reach the point, both the point is this particular way. So here I am highlighting the new path in red color. So this will be the second possible way to connect both the points 3 1 and 1 3. So now let us calculate the cost for this particular path. So A is 1 and then Z is 26, so 27, and then again A, so 28, and then again A, so 29, and again A, so 29 plus 1 30. So the cost for this particular path is 30. So now we have calculated the two path and we have calculated the cost for both the path. Now our task is to print the minimum path. So out of 6 and 30, 6 is the minimum. So in our output we are printing 6. So that will be the minimum cost required to connect both the points. So this is how we will be solving the question. And suppose here the point is 3 1 and 1 3. So let us assume the point is 3 1 and 3 3. So here what happens is this will be the point 3 1 and then 3 3 will be here. So now we have to connect these 2 points. It is given in the question that there is only horizontal and vertical movements allowed, and if both the point are in either same row or same column, then they should be connected directly. So there should not be either horizontal or vertical movements. So in this case both the points are in same row, so they should be connected directly. So now the cost for this particular path will be A plus Z plus A. So A is 1 and Z is 26. So 26 plus 2 is equal to 28. So this will be the output if the coordinates are changed like this. So if the 2 points are in either same row or same column, then they should be connected directly. If both the points are in different row and different column, as we saw the first example, then we have to connect them in 2 possible ways and find the minimum path. So first I am creating a function named min, which accepts 2 integers in its arguments, and this function should return the minimum of both x and y. And similarly another function named max, so this should return the maximum of both the integers x and y. And now coming to the main function, first I am creating some integer variables r, c, x1, y1, x2 and y2, and in the next line using a scanf statement I am accepting the values of r and c. So here after %d we should give /n, because next we have to accept a character matrix. So now to store the character matrix I am creating a 2-dimensional character array named mat of size r cross c, and then using a nested loop we have to accept the r cross c characters, and after the r cross c characters we are given the 4 integer variables. So again using a scanf statement I am accepting those integers as input, and I am decrementing the value of x1, y1, x2 and y2 because the index starts from 0. So that is why we are decrementing all the values by 1. And then I am creating an integer variable named minimum distance, and whenever we want to find the minimum, initially we will assume it to have a maximum value. So I am assigning a big integer number to it. So now first we are going to check whether both the points x1 y1 and x2 y2 are in same row or not, because if they are in same row then they should be connected directly. So if they are in same row, then the value of x1 and x2 will be equal. So in the first if condition, I am checking whether x1 and x2 are equal or not. If it is equal, then we will be finding the minimum distance within here itself. So first I am creating an integer named sum and I am setting it to 0, and I am creating a j loop that iterates from the minimum of y1 and y2 till the maximum of y1 and y2, so that we will be connecting both the points x1 y1 and x2 y2, and in every iteration of this loop we have to calculate the path for that particular character. So first we are going to convert the character into the lowercase. So the character present at the index x1j will be converted into a lowercase, and we will subtract it with a, because if we are going to take the character as a, then its value should be 1. If b, then it should be 2. So what we are going to do is we are going to subtract with a, and if you are going to directly subtract with a, then it will become 0. So I am adding plus 1, so that we will be getting the correct values. So after the execution of the loop, we would have calculated the sum. If sum is less than minimum distance, then we will be setting the minimum distance is equal to sum. So this is when both the rows are equal. And now there can also be another case that both the columns are equal. So here again in the else if condition, I am checking whether y1 is equal to y2. So again we have to implement the same logic. First I am creating a sum and I am setting it to 0, and the loop iterates from the minimum of x1 and x2 till the maximum of x1 and x2, and in every iteration we have to calculate the cost. So I am adding sum with the lowercase of the character minus a plus 1. So finally after the execution of the loop, we would have calculated the cost for that particular path. So if it is less than the minimum distance, then we will be setting minimum distance is equal to sum. So if either both the rows or columns are equal, then we would have calculated the minimum distance over here itself. Only when both the row and column are different, we will be coming into this else part. So in the else part, we have two possible ways to connect both the points x1 y1 and x2 y2. So the first possible way will be making the rows equal and then the column. So here we are going to implement a logic for that. First we will make the rows equal. So from the x1 row we are going to reach x2. So first we are checking whether x1 is greater than x2, because if it is greater, then we should decrement, only then we will be able to reach x2. So if x1 is greater than x2, then I am creating a for loop that iterates from x1 to x2, and we will be decrementing the value of I, and in every iteration we will be adding the sum. So after the execution of the loop, we would have made the rows equal, and we would have also calculated the cost for making the rows equal. So this is when x1 is greater than x2, and in some cases x1 may be less than x2. So in those cases we have to increment, only then from x1 we will be able to reach x2. So in this case, the else part, the loop iterates from x1 to x2, but here we will be incrementing, and again we will be calculating the path for the particular traversal. So either if or else condition will be executed, and we would have made the rows equal. So now we have to make the columns equal. So again after this if else condition, again we have to create another if else condition. So here we are going to make the columns equal. So if y1 is greater than y2, then we have to iterate from y1 to y2, and we have to decrement, only then we will be able to reach y2, and in every iteration we will be calculating the path. So here I am iterating from y1 minus 1, because already we would have reached the point y1. So in order to remove the duplication, we are iterating from y1 minus 1. So either this part of the code will be executing, else the y1 will be less than y2. So in those cases, this for loop will be executing. So we will be iterating again from y1 plus 1 till y2, but here we will be incrementing, and again in every iteration we will be calculating the cost. So finally after that execution of the loop, we would have calculated the total cost to connect both the points x1 y1 and x2 y2. So if that particular cost is less than the minimum distance, then we will set the minimum distance is equal to sum. So this is the first possible path, and there is another possible path. So before that I am making sum is equal to 0, and the second possible way is, first we have to make the columns equal, and then we have to make the rows equal. So now we have first made the rows equal, and then we have made the columns equal. So in the second possible way, we have to do the opposite. First, we have to implement the logic for making the y1 and y2 equal, and then we should make x1 and x2 equal. So when you are going to do like that, we will be getting a new sum. So if that sum is less than the minimum distance, then we will update the minimum distance is equal to sum. So finally, after the execution, we would have calculated the minimum distance to connect both the points x1 y1 and x2 y2. So we will print it. So this is the logic to solve today's daily challenge. Thank you for watching.